Welcome to part 3 of the 3D printed frame for the electric inline skate. Now we are gonna disassemble all of this to show you how it's done. But first, let's talk about how it's actually made. Okay, here is the skate and you can see the 3D printed frame right here. On this instance, I put only one motor on the back, on the rear wheel, and I have a normal inline skate wheel on the front. When I put it like this, you can see I have a really big spacer here and there, and they are actually not in the same length because the motor itself has this part here, so it's not centralized. Here you don't have that, see? So I needed to make for this. So when you look like this, you can see like here, and here is like longer as well. This prototype doesn't have the battery inside the frame. It only has the ESC here, the electronics. So the wiring from the motor goes through here, like it comes out of here beside the axle and goes back inside here to the electronics. And then you can see here is the port to connect the battery, and the wire goes on your leg up to your backpack where your battery is. So only the wire come here, the electronics are here. So first of all, why the electronics are here and not on your backpack together? From the motor, we have 3 wires and they are really high amperage. So if I wanted to get these wires all the way to my backpack, I would need like very thick wires, like really strong wires going all the way in three of them. Here, I only have a high voltage, like 36 voltage from the battery and not as much amperage as on these. So and also this is only 2 wires, so this is much simpler than getting the 3 wires up. Also, as you can see here, this frame is 2 side walls. They are like printed flat on the bed. And this white part here, it serves 2 purposes. One of them is to protect the electronics from debris, like here, to just throw rocks on it. So you need this to protect the electronics inside. But also you can see that we have a little bit of, we have 2 bolts here and here. So this actually adds a lot of rigidity because this is 3D print, right? This is plastic. So of course it twists a little bit. So we have this bolt and then this one and this one and this one. And since they are supported from the inside here, since they're supported here and here, right? I can tighten it a lot. So like I can really tighten it. And this, like 3D prints, they are really strong in a compression setting. But they're not strong when you push them this way or when you twist them. So when you compress them this way, really strong. So this adds a lot of rigidity. Also, the part here that connects to the boot, and you can see right here, it's around here. This part here is black. It's a little hard to see, but I will disable it soon when you see it. This part, it serves the same function. You compress it with the bolts, so it adds rigidity to the frame. So let's start disassembling it. I'm gonna start with the front wheel. As you can see, it's a solid bolt and 8 millimeters in diameter. Now let's take off the wheel. As you can see, it's a normal, this is a 110 inline skate wheel, which is not new, so it's less than 110. Since the motor is 105, this should be around 105 as well. And here are the spacers. As you can see, they are 3D printed. Because it's not a really beautiful print, because I just printed really fast. I didn't need it to be like pretty. So it connects the wheel like this, and this serves as just like it touches the wall, so it helps a little bit with this. Okay, now let's take off the motor. Actually, before we take, okay, now let's take off the boot. So I'm gonna take this off, but my scale wheel doesn't fit here. No, it doesn't fit here. So we're gonna use this little thing here. As you can see, these are two bolts. These are not as strong as the axles, of course, you don't need them to be. These are 6 millimeters, like these are not 6, these are imperial, and I will never remember the units in inches. So it's around 6 millimeters. Okay, so now this. So before we dive into the frame itself, let's go over this. You see here, you can see the screw from the boot. This is a shadow boot, okay? This is a shadow, which now it's called shadow. Anyway, this is the same boot as a dupe, but aggressive. Anyway, let's go. As you can see here, this is 3D printed. Yeah. I use this because you need a little bit of adjustment. All of these holes have this slit kind of thing because it really depends when you're gonna tighten all the screws together. Sometimes you need a little bit of wiggle, like half a millimeter or so. So that's why. So this is the thing that actually gets the frame into the boot, like this. So if I want to change from UFS to SSM, like with the heel higher, I just need to change this part. I just need to get a slightly higher one. Okay, finally we can take a look inside the frame. So like I said, this is just one wall, another wall here, right? Okay, now I'm gonna take off these two. Okay, let's take them off. This is the same bolt as this. So they come together here, here. And now this part gets out. So this part here, like I said before, this is for compression purposes to add a little bit more torsion rigidity to the frame. And it's like this, so it can actually act like a mud guard for the electronics. I could do this like higher and fully protect everything, but then I might have a problem with cooling the electronics. So I need a little bit of air to go through to cool the electronics. Okay, now we can take off the electronics. And here you have the power button. Let's just take it off the electronics here, right? And this is the 3 wires that go to the motor. Yeah, these, you can see these wires are rigid, solid wires. They're a lot more expensive than like normal electric wires you have at your home. So about the ESC, this is a generic electric skateboard ESC for 2 motors. You can see you have like 1 motor here and 1 motor there. This is the place for the battery to connect, and this is the wire for the antenna. Okay? This also has a battery monitor, which is like an LED indicator. You can put it on your build as well. I didn't use it because it shows on the remote control, so I didn't think it was worth it. Okay, it is all sealed inside this box. Not waterproof, but with this part, it should withstand splashes, no problem. You cannot submerge it, but a little bit of splash, it should be fine. Now, the most interesting part of this build is actually this part right here. That is the steel part that actually the motor is actually pushing, right? So I'm gonna take off the motor and then I'll explain that part. So here we can see the frame. Oh, let me take off this washer. Okay, here's the frame with the power button here. The power button, oh, okay, I'll just show it because some people might not have never seen how a button is put on. So it has a little nut here, and then it just goes like this. So this is actually not completely necessary, but I like because it has an LED here that shows if it's on or off, so I like it. Okay, now we have this plastic spacer here, which is also 3D printed. The only purpose of this is actually serve as a support to the frame. Let's see how it's doing. This is 3D printed. I actually tested this a little bit, not a lot, and it's holding very well. You can see that here. It doesn't show any sign of wear. It's perfect. Nice. Now take off the motor. You see here, if you see here, the wires are so close to the, I have to take off the wires first. Yeah, I made it like really tight, so I didn't have any wiggle, and it worked very well. You can also shorten these wires. This is not a problem. Also, you can see here, this is the Hall sensors wires, which we are not using. We don't need to use those. They just make the motor smoother on really slow speeds. So we don't need that. So this is the motor, right? You can see it's like a generic electric skateboard motor with a rounded tire. This is not really soft to the touch, but you can actually, let me see if I can show you. You can see it's softer than a normal inline skate wheel. So this is really good grip on wet terrain. So I really appreciate that. And like here. So this is slotted place here is where the motor actually needs to lean on to actually get the torque on something. Because if you, like the wire, the bolt here, the axle, it doesn't actually lock the inside of the wheel, okay? So what locks is this. So you can see here. You can put a bolt here. You can put a bolt and you like roll freely. That's not what we want. We want this part to be locked, like really locked in place, so this rotates. That's where this part comes in. Oh, by the way, just showing you the washer, what I had to do with the washer here. Because it needs to go here and because of the wiring. See? If it was like a complete washer, it wouldn't fit. So I need like to cut the washer. So here comes this. This is the part that actually makes all of this work. Because here you put the axle in, but then you have the square tool slot here. So you get here, and then it locks there, right? And it's slightly curved, so it doesn't hit there. So now we can like hold here, and then the motor will spin the way we wanted it to spin. So this goes here, right here. But then, if I only put something like here, it would still spin. I could do like a rounded thing here and glue it to the frame or screw it to the frame. But I thought that like the vibration would eventually wear down the frame because it's a 3D printed frame. It would wear down the frame where it was. So let's go with a passing bolt here and here. It would be enough to hold the torque. But then all the doing this and this would eventually wear it down. So what did I think of? Okay, let's just put here and support with the other screw. So it goes like this. So this other screw here, this is the one that the two of them actually hold the torque. So there will be no wear and tear on the frame itself because of the torque, because it's supported by a steel piece on two axles, two bolts. If you guys want, I will make a video about how I did this. This was actually a nut that I welded to a steel piece here, and then went with the power tool and then sand it down until it's like this. So it's not pretty, but it works. Of course, I am trying to figure out how to do this with 3D printing, but so far you need a welder to do this, unfortunately. So I'm working, if this goes ahead, I could try to make just this one part for everyone. So if you were using this motor, I could have this. Okay, so what are the benefits of using this? Of course, anyone can actually 3D print one frame at home, right? Or you have a friend that has a 3D printer, or you have a service that you send there to print. Okay, it has 13 millimeters thickness here and 3 here. So it's really strong. You can see it flex a little bit, but it doesn't write like this. It doesn't. So this way, no. This way, yes. So that's why we have all the other pieces that go together to actually make more torsion resistant. So when you have all of those, they don't twist at all. So yeah, you could print these in one piece, or you could send somewhere else to print in one piece. So I still need a lot more testing to see if this is actually strong enough. But I will put my STL files on some platform, I think on Codes 3D or something, for you to actually take a look at it. And if you actually buy the parts to do one, you can print mine, or you can use it as a reference to print your own frame. You can print it like thicker, you could print it like shorter, longer, whatever the way you want. This is just to show you that it's possible. This was made on an Ender. Actually, no. This was made on a CR10 Creality, which is a big printer, but a cheap printer. It's affordable. So you have two, all of them are like equal, they're the same piece. So I don't have left, right, front, back, they're all the same. You can put 4 motors here, or you can use 2 motors, you can use 1 motor. Man, you could also put 2 wheels on the front if you wanted to. There's enough space to put 2. You just needed to make the different spacers. So there you have it. Okay, so this is how I actually build this version of Thunderblade. So if you have more questions and want to talk to me, get in our Discord server. The link is on the first comment and in the description. So hopefully you learned how to build one yourself, and soon enough we all will have electric line skates and we will storm the streets.